In the name of God, hello everyone. My name is Masood. I'm a physics teacher. I want to welcome you to Ferkhwa's website. Also, we have an application. You can download it on your cell phone to follow our videos. And we will be happy to be with us to the end of this curriculum. We plan to, let's say, film the whole book for you. And we try to make the physics easier for you as much as possible. Right now, I'm going to explain the last subject from the chapter 1, which is the gravitational force is localized to the center of a spherical mass. Right? This is the title of the subject. Let me explain the subject. Actually, this last subject. Firstly, let's say we want to prove this equation. Where does this equation come from? G small free fall acceleration is equal to G capital universal constant of gravitation multiplied by M capital E, means M sub E, mass of our planet, mass of Earth, divided by RE square, divided by radius of Earth square. Actually, let's say I got this figure from this website. I changed something from the figure, but the information it's not for the website. Things information is we have this information in our textbook. I take it out from our textbook, right? Just the figure for this website, right? I appreciate them. Consider a particle. Consider a particle of mass m. This is a particle. Right? I put this particle here. The mass of a particle is m small because it's a way, let's say, smaller than the mass of Earth. You know that the mass of Earth is enormous object. It's a more massive object. That's why, let's say, the mass of the particle is denoted by m small, right? And the mass of Earth is denoted by m capital. Gravitational force between two objects is calculated by this equation, the previous equation, right? You know this equation, I explained it for you. Fg is equal to G capital, m capital, m small over r squared. Name this equation for me. What's this equation? Universal law of, let's say, gravity or gravitation. The particle is being pulled by Earth. The particle is pulled by Earth actually, which leads to the particle's weight, of course, and Fg is equal to mg. What's the weight of object? What's the weight of you? Think about the weight of yourself. How much is the weight of myself actually? What thing creates my weight? What thing creates weight of any object? Actually, weight means the measurement of gravitational force of Earth on any object above the surface of Earth. Or simply we can say gravitational force of Earth on an object. So mathematically I can say Fg is equal to mg. This is the weight of object, and we can say gravitational force of Earth on an object. And it's calculated by this equation mg, right? Focus on these equations. Take a look at these equations. Is there any, let's say, analogy between these equations or not? Do you see any similarity between these equations? I'm sure you see the similarity between them because the left part of these equations are coincide, right? They coincide. The left part are, let's say, the left parts of these equations are corresponded to one another. They coincide with one another. That's why in physics, if the left parts of two equations are corresponded to one another, you can equate the right part as well. It's okay in physics. It can be in physics. It's accepted. So mg is equal to G capital, m capital, and small divided by r squared. I, let's say, wrote this note for you by equating equations above. right? So here, can I cancel out mass of object with, let's say, in either side? It can be. So the only, let's say, equation, let's say the equation, we got the equation G is equal to G capital, G small is equal to G capital M capital over R squared. So M is cancelled out uh, from the, let's say, fraction, from the equation, and we could prove the equation, right? That's it. We have a, let's say, maybe you say, teacher, what's the meaning of canceling out of mass in either side of the equation mathematically or physically? Mathematically, actually because they are common, because uh, it's repeated in both, let's say, sides. You can, let's say, simplify them mathematically, but physically has a, let's say, has a great meaning. Physically, you can say, let's say, you can deduce some very nice information about, let's say, this canceling out. Why do we say this? Why does, let's say, mass, let's say, simplify in both sides of the equation? Because, let's say, because acceleration due to gravity or free fall acceleration does not depend on the mass of object. Only G depends on the mass of planet. It does not depend on the mass of object. So mass of object doesn't matter, right? Whether the object is, let's say, small or large, no problem. Compared to the mass of Earth is nothing. That's why acceleration due to gravity of Earth is only one number, which is 9.81 meter per second square, right? If you substitute this value, for example, these values are all constant. This is G 6.67, right? Times 10 to the power negative 11 multiplied by mass of Earth, approximately 6 times 10 to the power 24 kilogram, divided by radius of Earth, approximately, I can say, 6.4 times 10 to the power 6 meters. I'm not sure about the, for example, radius, because I know the, let's say, diameter of Earth is 12,756 kilometers. If you divide this number by 2, you can find the radius. I'm not sure about this number, no problem, but you have to, let's say, square it as well. If you, let's say, substitute, I wanted to tell you these, let's say, these quantities are all constant. That's why mass of the object does not matter. I'm going to give this example for you. Let's say, every year when I reach this subject in my class, I give this example for my students, and I'm gonna, let's say, repeat this example. Imagine there's an elephant and there's a mouse, right? Elephant, let's say, is of, let's say, thousands of kilogram, maybe 2,000 kilogram or 2 ton or 3 ton, right? 3 tons. What do you say about the, for example, mass of a mouse? Maybe it's about, let's say, it's in grams. It's measured in grams. So there are two objects. Elephant is a very huge object, is a very massive object, versus a mouse, which is a very light object. Whenever it's an imaginary, actually, it's an imaginary experiment. Bring the elephant and mouse, let's say, to the top of a building, and I want you to throw them down, right? Whenever you drop them down, let's say, tell me about the acceleration due to gravity of Earth on mouse and on elephant, right? What do you say? Do you say, for example, G for elephant differs from G of mouse? No. So you say the only, let's say, you see only the one number, G is equal to 9.81 meter per second square for all objects above the surface of Earth, whether it's an elephant or a mouse, right? So this is a let's say convenient example for understanding this subject, and keep in mind that keep in mind that G is constant for any object, regardless of their masses, right? So question number one. Let's say only we have one question here. Let's say related to this subject. Let me erase the other parts, and I'm gonna discuss it with you, and I explained it for you actually in advance. It says y equation G is equal to G small is equal to G capital M capital R divided by R squared does not include mass, right? Why doesn't involve mass? Why doesn't equation involve mass of an object? Why? I explained it for you. Let me read the answer. Because acceleration due to gravity, look here, means free fall acceleration, means G is small, does not depend on object's mass. That's it, right? Think about a mouse and let's say elephant. So G for either objects is the same. Hence, G is equal to 9.81 meter per second squared on Earth's surface, regardless of the mass of the object. Or maybe, let's say in grade 11, we put negative for determining the direction of let's say gravity or acceleration due to gravity. It points negative. I told you in physics, negative differs from negative in mathematics. Negative in physics means direction. Here, whenever you, let's say, you designate, let's say, negative sign for here, negative sign for G is equal to negative 9.81 meter per second square. It means that the objects, that the Earth pulls the object toward its center. Means acceleration due to gravity is directed toward the, let's say, Earth center. It's directed to downward. I appreciate you guys for watching this video. I hope you enjoyed this lecture and this lesson, and bye for now.